Okay, I give the floor now to, wow, so small, to Alice Bertoletti. Time flies, also my age is. Exploring the influence of maternal and teacher role models on gender differences in maths.
Okay, thank you everyone. So I will present today this work. It is indeed about the effect of female role models on math achievement of Italian students. And the motivation is, as we know, in Italy exists a notable gender gap, especially in mathematics, in disfavor of girls. And this is particularly important since this gender gap in mathematics tends to also influence the career choice of girls, with a lower representation of women in a STEM career. So the literature about gender gaps among several mechanisms tend to identify also the role models as a mechanism to tend to mitigate the gender gap. And this seems to be particularly important for females and math, since it's able to reduce the stereotypical view about girls and STEM subjects. And about the role models for females, there are identified two role models. One is mothers and teachers then. So from the literature we know basically that the mothers can be an important role model because most of the students tend to identify as one of the parents or the relative as a role model. And in particular for girls, this is important because mothers are found to have influence in their daughter's self-efficacy and also their interest. What about the effect of having a teacher as a role model, in particular the literature, especially based on the US, data tend to identify a positive effect of having a same-sex teachers for students. And this in general is positive, significant, but not very, in terms of size, large, not very large. But then it's true that then studies that are focused on females, especially in math, they found a larger size of the effect. So the idea, given this context, this paper analyzed two research questions. First of all, is about how measuring the gender gaps in a precise way, in particular over the overall career of the grades of education of students. So also focus on the evolution of this gender gap. And the second is about these female role models, what is the effect in potentially mitigate the gender gap in the field of girls. So the first step of the analysis, these are based on the first, these INVALSI data, and these are the population students of INVALSI data, and using this set of data for measuring the gender gap and also to focus on the effect of mothers' role models. So basically these are the data, in particular since also the idea is to see the evolution, I'm using a longitudinal data set. The idea is indeed to match the same students over grades, in particular from grade 2 to grade 8. And in this case I'm using the last cohort before COVID. So from 2012 in grade 2, they are going to at grade 8 in 2018 and 2019. So these are the data. Of course, there is also part of the attrition, so we lose information on matching this data, but this is also taken into account later on in the analysis, as we will see. Okay, since the idea is having this longitudinal data, to exploit this I'm using a dynamic panel model. So it's a dynamic model because I'm using as a covariate the past performance of the students in the past grade that I can measure with INVALSI. And also to correct for this endogeneity, of course given from the fact there is this dynamic term in the model, I using also as a model an EV approach to correct for this. Okay, these are the results about the gender gap overall in all grades in this dynamic model. With different models and different samples, basically what you have is a consistent gender gap. The main difference, it's interesting here, I think, is between the dynamic model and not dynamic model. So the not dynamic model tends to overestimate the gender gap. It's almost the double, we say, of the gender gap. And this is particularly makes sense since if we think about what is measuring the dynamic model. So in a not dynamic is overestimated because I'm measuring in each grade a gender gap that is also taking into consideration the gender gap that was already there in the previous grades. So this is the logic why this size is larger for not dynamic. And then I can do the same for grades, in particular since I'm using grade 2 as a past performance. In grade 5 I can do it only for grade 5 and grade 8, and grade 8 I'm using grade 5 as a previous performance. So here basically is a confirmation, and it's interesting to see that as the literature also point out, that the gender gap is larger in a previous grade, so in this case grade 5 rather than a grade 8. Also, I have a lot of results, so I'm going fast, but this is also some information about the regional differences. And I can see there is, you can see also the map, there is a huge division between north and south, but I think it's very interesting to see what happens if we plot the gender gaps with division between grades, and we found a really opposite pattern. So in the north, the girls start with a larger gender gap at grade 5, but that are able to recover it later on, and it is completely opposite in the south, where there is not such a huge gender gap in elementary school, but then is increasing at grade 8. So this is about then what is the effect of this mother role model. And we don't have a lot of information about mother, but what the idea here is to use the employment status of the mother, basically if it is employed or not. And then also I have some results about mother's education that I'm not showing here also because they are not super interesting, so I don't have time now to present this. So basically what we have is that indeed, what this is an interaction, what these results are saying is that girls are more negatively affected by having a not working mother comparing to the counterparts of the boys in the class. And so in this case, since also I have this difference between boys and girls in perceiving the role of mothers, I can see that there seems an evidence about maybe the existence of these role models for girls. Then I'm going to the second part of the analysis about the teacher's role model. Here I'm using a different data set because I have to match the data of students with the data of teachers. With INVALSI, data of teachers, I have only information about not the overall population of teachers, but only on a representative sample of teachers. So, of course, I am referring to lower number of observations that I have to match in the same way. Also, I have the match between through the class between student and specific teacher. So in this case, we have a larger number of observation. I have to use, in this case, 3 cohorts. And also very important, I focus only on elementary school. Since here the idea is to focus on the role of teachers, very important, the school, so it's a little bit complicated if I have to compare also middle school and elementary school within the same analysis. So I will focus only on grade 2 and the grade 5 that are within the same school, and so also here I'm taking the latest course before COVID-19. So this point is that I'm losing a lot of information, so here attrition is also more important, and we see it has also using inverse probability weights. Before I didn't show up, but I also was using this, but with not a great difference in the results. And also, very important is that I'm comparing sample, like the male teacher, the numerosity of male teachers is very low compared to the nominal to female teacher because we are in elementary school. So there are a lot of female teachers. So in order to correct this bias, this structural bias, I'm using propensity score weights to improve the comparability. Then these are just to see, also in this data set, is different data set, different cohorts. I still have a gender gap, this is coherent from before, and this is also consistent across all the cohorts I'm using. Here, so the first result is very basic, is what is the effect of the average treatment effect of having a female compared to male teachers, and focus only on female students here. And here are basic results of propensity score matching results, and with the non-dynamic model for grade 2 and then for grade 8. What I have here is that, yes, indeed there is a positive effect, but it's not super statistically significant. It's not statistically significant in grade 5 and only slightly in grade 2. But what's about if I'm using a more complex model, is still the dynamic model we were presenting before. In this case, I'm using also the propensity score weights to correct for the bias I was presenting before. And so in this case, I focus on grade 5, because of course I can only focus on grade 5, taking as grade 2 performance, the previous performance in the model. And what I found here is that indeed there is an effect of female teacher. This is quite high, it's half a standard deviation. And also when I'm correcting for the weights, also the inverse probability weights to report this to the national sample, the overall population, let's say, of students. This is also quite significant in terms of statistical significance. Also, to enter a little bit in the mechanism, what I can see is that the interaction, I will focus on the first column, and this basically is the interaction between the gender of the teachers. We're still in a female, only female students, and the sex of the teacher in the previous grade, at grade 2. And what here is, I found is very interesting, is the first line. It is comparing for the reference categories the female students having a male in grade 2 and still a male teacher at grade 5. And if I compare to the one that had a male teacher in grade 2, but then they changed to grade 5 having a female teacher, I have a really large effect, almost a 1 standard deviation. Is very significant. And this is because also having, for example, the third line, female and female, is positive, not so much large in size, but this is in somehow expected, but in fact it's a dynamic model, so the shock I have it here is more on the first line, when I change the teacher, the sex of the teacher. So it somehow is expected these also larger results in terms of estimates. And this is the last slide about the results. This is also to have a comparison, a counterfactual. I also include the boys in the male students in the analysis, and I see that this effect of having a female teacher basically exists only for female students. So it's indeed to say that this role model is working for female students, but is not working the same way as boys. And also I think it's so here basically is a three-variable interaction. Is a bit complex. What the question is, when is beneficial to change a teacher having also a difference of the gender later on? And this is only beneficial if for female students that start with a male teacher in a grade 2. So for them is beneficial. This also when I take it out, the variable is negative variable of changing teacher. So in general, it's not about gender, but this is a negative effect, as we can see in the second and third column. But also when I don't include this, this variable is still significant and large effect is in the first column. So just to conclude, what is the conclusion of this work? In general, there is a gender gap, and I can estimate better this gender gap evolution using a dynamic panel model. And related to the female role models, there is indeed existence of a maternal role model, in terms of the difference between working and not working mothers, but has also a larger effect in the role of teachers. And in particular, this is a quite interesting result, because in terms of policy implication, this could be an effective tool, especially because it's improving the mathematical achievement of course, but without really harming the boys' performance. So I don't have an effect of boys' performance or having female teachers in general. So thank you for your attention.